A very good evening and selamat sejahtera to lecturer Sir Amir Izani. Today I'm going to present test 2 for Fundamental and Circuit Analysis 1 Lab. My name is Suman Anak Ramesh, section 02, ID number TG20023. So for part 1, experiment steps, first we need to build resistor networks according to the circuit diagram in figure 1 and record the voltage measurements at R1, R2 and R3 and point A, B. So this is the circuit in figure 1 and okay. So this is the circuit that I built based on the circuit in figure 1 and when I run this, okay. So now the voltage across point A and B is 0. The voltage across R1 is 4 volts. The voltage at R2 is 8 volts. The voltage at R3 is 4 volts and voltage at across R4 is 8 volts. So based on this reading, we need to record them into the table. So this is the table, and based on the value obtained from the multisim, we record them here. So the next step is build the resistor network according to the circuit in diagram figure 2 and also measure the voltage across resistor R1, R2, R3, R4 and point AB. So this is in figure 2. This is figure 2. Okay. Okay, so based on the figure 2, So based on the figure 2, I built the circuit, and when I run, the voltage I get across point A to B is 4 volts. The voltage at R1 is 4 volts. The voltage at R2 is 8 volts. The voltage at R3 is 8 volts, and voltage at across R4 is 4 volts. So this value we record them in this table. So we got 4 volts, 8, 8, 4, 4. Okay, correct. Next, based on the measurements results in table 2 and table 4, what is the condition or states for both circuits in figure 1 and figure 2? Please justify answer. So, okay, based on the figure 1, we can see that the voltage across A and B is 0. So, when the voltage is equal to 0, that means the bridge in figure 1 is balanced. It is because the voltage reading from the multimeter is V equals to 0. The voltage is 0 because there is no current flow across the point AB. Based on the theory that we learned, when the bridge is balanced and the current flow through point AB is 0, the voltage reading will be 0 too. So that's the for figure 1. And for figure 2, let's see for figure 2. In figure 2, the voltage across point A and B is 4 volts. So that means the bridge in figure 2 is not balanced. It is because the voltage reading from multimeter is 4 volt. The voltage is 4. It indicates that there is current flow across the point AB. Based on theory, when the bridge is balanced, the current flow should be equals to 0, and which gives the V equal to 0 too. But in this experiment, for figure 2, a voltage across AB is not equals to 0. Therefore, it proves the bridge is not balanced. Now for part 2, by referring figure 3, use the voltage divider equation, calculate the voltage drop at resistor below using R4 as the full value of potentiometer. So based from this figure 3, we need to calculate the voltage drop, and we use the R4 as 200, which is because 200 ohm because you have to use by 100%. So this is the calculation for VR1, VR2, VR3 and VR4. So now for VR1 equals to Vs times R1 over R1 plus R2, which is 12 times 50 divided by 150, which I get 4 volts. Next, VR2. We use the same formula by replacing here R2, so that we get VR2 equals to 12 times 100 over 150, and VR2 is equals to 8 volt. For VR3, we use R3 divided by R3 plus 4, so which is 12 volt times 50 over 250. Why we use 200? Because we use 100% of the R4. Now we get VR3 is 2.4 volt. Now VR4 Vs times R4 over R3 plus R4, which is 12 volt times 200 divide 250, which VR4 is equal to 9.6 volt. Okay, so the next question is calculate the voltage between point A and B. So to calculate the voltage points between the points A and B, we need to know voltage at A and voltage at B. So now voltage at A, we use the formula Vs times R2 over R1 plus R2, which we will get 12 times 100 divided by 150. Now VA is 8 volt. Okay, now for VB use the same formula Vs times R4 divided by R3 plus R4. Now 12 times 200 divided by 250, and VB is 9.6. Now to find the voltage between point A and B is by minusing voltage A and V voltage at B. So 8 volt minus 9.6, which voltage across A to B is negative 1.6 volts. Okay, so number 6, calculate the value of the potentiometer R4 to balance the bridge and justify your answer. So now, by applying the Wheatstone bridge theorem, the ratio is R1 over R2 is equals to R3 over R4. Now here, R1 is 50 ohm, R2 is 100, R3 is 50, and R4 we need to find. So by multiply in opposite, so 100 times with 50 and 50 times with R4. So we'll get R4 is equal to 50 times 100 divided by 50. R4 is 100 ohm. So to balance this circuit, to balance the bridge, the R4 should be 100 ohm or 50% of the 200 ohm. It is because the ratio of R1 over R2 to R3 over R4 is 1:1. Hence, it shows that no current flow from point A B. When there is no current flow, this proves that the bridge is balanced. Now here, to prove that the ratio that to prove that our ratio is 1:1, we use back the R4 as 100. So now 50 over 100 and 50 over 100, we get 1 equals to 1. So the ratio is 1:1. Therefore, it's proof that the bridge is balanced. So that's all. Thank you.